The Voyager probes have been traveling through the universe for more than 45 years, and we wonder what will actually happen to these two probes in the distant future. Will they really reach a distant star system and possibly encounter aliens there? And where are NASA's Pioneer probes, which were also launched in the 1970s? Voyager 1 and 2 were launched in 1977 to take advantage of a special alignment of the outer planets, Jupiter, Saturn, Uranus, and Neptune, which were practically in conjunction and easy to reach, as they only align every 175 years. NASA quickly put together two probes that have since made world history. Voyager 1 and 2 first traveled to Jupiter and Saturn as part of their original mission, with Voyager 2 also exploring Uranus and Neptune for the first time. Scientists use gravity-assist maneuvers to propel the probes through the solar system in record time. Just a few years after launch, both probes provided photos and scientific findings of Jupiter and Saturn for the first time. Voyager 1 transmitted the first high-resolution images of Jupiter's trademark, the Great Red Spot, and recognized that it's a storm. The probe discovered active volcanoes on Jupiter's moon Io and documented the complex ring systems and moons of Saturn. Voyager 2 continued its journey and became the only probe to examine Uranus and Neptune up close. It photographed the enormous ice giant Neptune and discovered new moons and rings around Uranus. Voyager 1 was already on its journey to the outer regions of the solar system, powered by a plutonium-238 radioisotope thermoelectric generator. The probe has now flown more than 24 billion kilometers into open space. Voyager 2 followed at a closer distance and is now also flying through the interstellar medium. Both probes are still sending data about particles, cosmic radiation, and magnetic fields every day. After more than 45 years of travel, the energy sources are slowly weakening, and NASA has been struggling with one or two malfunctions of the space veterans in recent years. So far, NASA engineers have repeatedly managed to get the two Voyagers up and running again. The experts have managed remote maintenance at incredible distances, and if all goes well, we can expect measurement data from the interstellar medium until the end of the decade. But what will happen after the last radio contact with Voyager 1 and 2, when the batteries have finally given up the ghost? Voyager 1 and 2 will still be flying, but they won't be able to send any more data to Earth. Calculations have shown that in about 40,000 years, Voyager 1 will fly past the vicinity of the star G445. By then, it will have traveled a distance of 17.6 light-years. Voyager 2 will pass close to the bright star Sirius in 296,000 years. Neither probe has a direct destination. Instead, they are drifting more or less aimlessly through the galaxy. They may continue flying for billions of years, and nobody knows when or if the probes will ever be found by anyone in case they fall into the hands of an extraterrestrial civilization. Both probes have a golden record on board. In reality, the plates are not entirely made of gold but rather gilded copper plates. They contain audio recordings of greetings from people in different languages, as well as images, sounds, and music from Earth. So, when their mission comes to an end, Voyager 1 and 2 will not just be decommissioned scientific instruments, but cultural ambassadors, carrying humanity's legacy into the infinity of space. Where are Pioneer 10 and Pioneer 11? Pioneer 10 and Pioneer 11 are often forgotten in all the excitement surrounding Voyager, but these two are still out there in space as well. Pioneer 10 and 11 were two of the first probes to explore the solar system. Pioneer 10 was launched on March 2, 1972, and Pioneer 11 followed on April 6, 1973. The primary goal of both was to explore Jupiter and Saturn, after which they were to continue into the outer reaches of the solar system. In addition to their visits to the two gas giants, both missions were also designed to investigate how interplanetary space functions at great distances. Pioneer 10 was the first probe to successfully cross the asteroid belt between Mars and Jupiter, paving the way for Voyager 1. In December 1973, it passed Jupiter at a distance of about 132,000 kilometers. Pioneer 10 provided the first close-up images of the gas giant and sent data about Jupiter's radiation, its extremely strong magnetic field, and its turbulent atmosphere. After that, it continued its journey into interstellar space. Unfortunately, the probe was no longer able to document the transition from the solar system into interstellar space in January 2003. Pioneer 10 transmitted data about cosmic radiation and the solar wind for the last time. Today, it is traveling at a distance of about 130 astronomical units, or approximately 19.5 billion kilometers from Earth, heading towards the constellation of Taurus. Pioneer 11 also explored Jupiter and, in December 1974, provided unique data from the inner radiation belt of the gas giant. To do this, the scientists steered the probe in a risky maneuver so close to Jupiter that it was a feat that Pioneer 11 survived this maneuver in one piece. Jupiter's radiation is among the most extreme in the solar system. After Pioneer 11 had easily mastered this mission, it transmitted more spectacular images of the ring system and discovered 2 new moons. Shortly afterward, it continued on to Saturn, and the probe also examined Saturn's magnetic field and provided the first measurements of the temperature of its moon Titan. After its mission to Saturn, Pioneer 11 also continued its flight in the direction of interstellar space. Communication was discontinued in November 1995 when the energy supply became too weak. Today, Pioneer 11 is probably about 103 astronomical units from Earth, which corresponds to approximately 15.4 billion kilometers. In many thousands of years, Pioneer 11 will probably reach a star system in the constellation of the Shield. Like the Voyagers, the Pioneer probes also have greeting messages for possible contacts with extraterrestrial species on board. As interstellar ambassadors, the 2 each have a gold-plated aluminum plate in their luggage. The so-called Pioneer plaques are schematic representations of humans, the Earth, and the position of our solar system in the Milky Way. The Pioneers were the first probes to report back from the outer reaches of the solar system, followed by the Voyager twins, and then it was quiet for a long time. NASA focused on exploring other destinations until New Horizons was launched in 2006. New Horizons' mission to Pluto and beyond was one of the fastest spacecraft ever launched. On January 19, 2006, it took off from Cape Canaveral aboard an Atlas V rocket. The probe's main objective was to study Pluto, which was then the 9th planet from the Sun. It was also planned that New Horizons would visit Pluto's moons and objects in the Kuiper Belt. The mission was designed by NASA as part of its New Frontiers program to gather new scientific knowledge about the still relatively unknown outer reaches of the solar system. New Horizons was the first spacecraft to explore Pluto at close range, and it provided the first real image of the dwarf planet. All the images we had seen before were artistic representations, and we had a rather blurred image taken by the Hubble Space Telescope. So, the first real encounter with Pluto was a historic moment in space exploration. After a 9-year journey, New Horizons reached Pluto on July 14, 2015. To achieve this record time, NASA experts used a swing-by maneuver at Jupiter in 2007. The probe used a flyby in contact with Jupiter's magnetic field to accelerate to speeds of several thousand kilometers per second. What many people don't know is that New Horizons never swung into Pluto's orbit. The probe merely flew by. The flyby lasted several days and provided spectacular images of Pluto's complex surface, images of vast ice sheets, glacier, and possibly cryovolcanic structures surprised the experts. Scientists had expected to discover a barren world of rock and ice on Pluto, but Pluto showed not only its famous heart but also an astonishingly active surface. The mountains on the planet are not made of rock but of ice, which is harder than rock on Earth. Cryovolcanism and active ice fields led to the suspicion that Pluto, like the icy moons Europa and Enceladus, is warm in its interior and possibly even has underground oceans with simple forms of life. New Horizons discovered that Pluto's atmosphere is thin and consists of nitrogen, methane, and carbon monoxide. The probe recognized that there are some weather phenomena on Pluto, with complex cycles of liquid and gas, probably seasonally snowing thick flakes of nitrogen ice onto Pluto's surface. After this once-in-a-century mission, New Horizons delivered shocking data from Charon, Pluto's largest moon. Contrary to previous expectations, Charon could be another small planet and not a moon like its partner Pluto. This moon showed a wide range of geological features, deep canyons, and smooth plains that made the researchers want to study the Pluto system even further. But that we'll have to wait for. New Horizons could not linger at Charon and Pluto. The planned route took the probe further into the Kuiper Belt. This zone, behind Neptune and Pluto, is a several 100 million kilometers wide zone of rock collections and home to some minor planets. On January 1st, 2019, New Horizons successfully flew by Eric, a peculiar Kuiper Belt object that sparked the special interest of researchers. The strange shape of two connected bodies provides researchers with important clues about the dynamics that lead to the merging of objects, and this data could also explain how misshapen small planets like Makemake or Haumea were formed. Now, do you also want to know where New Horizons is today? The probe is located approximately 8.2 billion kilometers from Earth. That's about 55 astronomical units, where 1 astronomical unit is the average distance between Earth and the Sun. New Horizons continues to move toward interstellar space. However, it will be years before it even comes close to the heliospheric boundary. New Horizons probably still has enough energy to transmit scientific data until the 2040s, when the probe's energy source, a radioisotope generator, is exhausted. This probe will also continue to travel silently through the galaxy as a testimony to our culture,